Hi, welcome, welcome. We are doing 11.5 today on page 50 in our note guide. These are areas of circles and sectors. It's really similar to what we did yesterday, which was circumference and arc length. So you set it up the exact same way, which is really nice. You just have to decide if you're talking about area or like circumference. So that's the only difference. We have a few warm-up problems here today. Area of a circle, maybe not warm-up, actually new step. Pi r squared. We should know this already though, so it should be reviewed. Find the area of a circle with the given information. So if my formula for area is pi r squared and I know my radius is 3, find the area of the circle. Area equals pi r squared, plug in your pi, 3 squared is going to give me 9 pi. Now, for the most part, anytime you would use that in class, you're going to leave it 9 pi. I'm not exactly sure how Alex will ask them, so you may have to use your calculators for some of these, but probably not. If you want an exact answer, you will keep it in terms of pi. So if I go 9 pi, though, most of us use 3.14. That's still rounding. So if you have a calculator that has the pi symbol, you want to use that symbol. So if you ever can use the symbol, that's what you would rather use. It's going to be more exact, 28.3. Now, I do not believe you're going to have to write it that way. I believe the preferred method or the preferred answer is going to be 9 pi. You want to keep it that way as much as possible. Now the diameter, well, diameter is equal to 2 radii. So that means that my radii would be equal to 9. So if I have pi r squared, I end up with 81 pi feet squared. And again, this is my preferred answer. You can always put it in your calculator and use the pi symbol if you have one. If not, go ahead and use 3.14. Okay, so now we're going to do the sector of a circle. The sector is the region of a circle that is shaded in. I have a handy-dandy little circle maker, which I love. So if you guys have seen this yet, it's pretty impressive. I want to create a circle. Here's my center. And let's say that this is my son's favorite ruler. He just told me the other day. Basically, the sector of a circle, the area of the piece of pie. So whatever this is, you would want to find the area of this slice of pie, basically. So we set it up. This should look familiar to what you saw yesterday. In the notes yesterday, you had something like this. I didn't complete them. But I usually put something over it like this. So I know that the part of the circle goes on top, the whole circle goes on bottom. So the arc length that I'm looking for, that piece goes on top, the entire circumference, the entire whole length goes on bottom. The angle measure of it goes up top, the entire circle goes on bottom. I set it up the same way each time. This is what's going to happen here. The part over the whole. So that is the entire area of a circle, pi r squared. The part of the area is at A, the part of the arc up top, and the entire degree of the circle on bottom. Every time it's the same, whether you're talking about area or circumference, same setup. Okay, so one way you could write this, if you know this is true and you're solving for A, that would make A equal to the arc over 360, so these would both be degrees, times pi r squared. So if you're going to solve this, that's what it's going to look like. Right here, find the area of the shaded region, set it up. area is what I'm looking for, so that's my variable. You can put A, you can put X, you can put whatever variable you want. The entire area is pi r squared. The radius here is 11. Again, pause. See if you can finish this problem on your own, knowing this information. The degree of the arc is 135. The entire degree is 360. Okay, well, I can divide these both by, let's see, 135 divided by 4. 135 divided by 5. I can divide them both by 5. I get 27 up top, divided by 5 down here, I get 72. Well, those are both divisible by 9. Divide by 9, I get 3. Divide by 9, I get 8. I can't divide any farther. So simplify as much as you can, if possible. I'm going to cross multiply. I'm going to get my area is equal to 3 over 8 times pi r squared is going to be 121 pi. Well, again, you want to multiply those together. So A will be equal to 363 pi over 8 units squared because it's an area. This would be your answer. Now, depending on what you're doing, analysis and stuff, you may be able to do that, compute that. I'm going to pause. I'll give you the answer to that. See if you can draw and set this up. Over here, in case you have to put it in a calculator, 363 pi divided by 8. And again, I'm going to use the pi symbol if possible, 142.5. I'm pretty sure you're going to keep it in this answer anytime possible. But sometimes you may have to use a calculator to have an approximate answer. Over here, so I used my handy dandy circle maker, my favorite little tool, and made this perfect little circle, LRM 150, radius of 5. I want to find the areas of the sectors formed by this angle. So first, the area of this sector, I'm going to call it A. A. The area of the entire thing is going to be pi r squared is 50 squared. This degree of that arc is 150. The degree of the entire circle is 360. Again, you want to simplify everything you can. I'm going to divide by 10. These are both divisible by 3, giving me 5 over 12. So I'm going to multiply by the area. I end up with the area equals 2,500, so I get 5 over 12, times 2,500 pi. Well, these are definitely both divisible by 4. So if I divide by 4, I get 625 over 3. 3 does not go into that. So my final answer here, A, is going to be equal to 5 times 625 is 3125 pi all over 3. Its area, centimeters, so centimeters squared. And again, I believe this is the preferred answer. We're going to go ahead and keep it here. Now, the next, it doesn't say just that sector. It asks for both sectors. So if it's asking for both sectors, I either want to do this again for this arc, which if this is 150, this over here is going to be 360 divided, subtract 150. This part over here would be 210. So I can do the same thing, make it 210. Or, if I know the area of the entire circle is 2,500 pi, and this is the area of this piece, I could subtract it. I could take the area of the circle and subtract the piece that I know. 3125 pi over 3. The area of the circle, I already know, is 2,500 pi. I'm going to go ahead and say 2,500 pi. Except now I want it to be a fraction. I want it to be a fraction, and I need it to have a like denominator. So I need this denominator, it's 1 originally, multiplied by 3, it's going to be 3. So if I multiply this by 3, this top is going to become 7,500 pi. So now it's the area of the circle where I can subtract. 7,500 pi minus 3,125. I'm going to end up with 4,375 pi divided by 3 centimeters squared. This is the area of that colored region. And this one here, I'll color code for us, is the red region. So there you go. Okay, now we want to find the area of this shaded region. So it's a circle with a triangle taken out of it. So you don't want the triangle, you want the circle without the triangle. So whenever I have something like this, I generally start by writing a plan. I like to know what I'm doing so I don't forget or lose track or do the wrong thing. I need the area, I'm going to draw a little circle here, minus the area of a triangle. So do I know the formula for area of a circle? Yeah, it's pi r squared. Do I know the area for a triangle? Well, yeah. I'm going to write area of a triangle over here equals 1/2 base times height. But when I look at this, well, first, do I know the radius? Right here I have a radius. That's this piece right here. I can go ahead and figure out the area of the circle. Pi 4 squared, 16 pi. Okay, so now, can I figure out this? Do I know the base? No. Do I know the height? No. Do I remember a formula I learned recently where this is a polygon and I can find the area of this if I know other sides? Well, yeah, the area of any polygon is going to be 1/2 apothem perimeter. Well, if this is a triangle with all three sides or angles are the same, then they have to be 60. If I cut this angle in half, this now becomes 30. I could draw the apothem right here. That would make this a 30, 60, 90. So if this is a 30, 60, 90, and if we remember, I like to draw it so I see it the same way every time. 30, 60, 90. Remember that this is my shorter leg is x, my hypotenuse is 2x, my longer leg is x root 3. Well, right here, they're telling me that the hypotenuse is 4. Well, if the hypotenuse is 4, then x is going to be 2, and the longer leg will be 2 root 3. That would make this right here 2, this right here 2 root 3, which makes the entire side 4 root 3. So, using our special right triangles, we can see these things. My apothem, I just decided, was 2. Now my perimeter, if this side is 4 root 3, my perimeter is going to be 3 times 4 root 3, giving me a perimeter of 12 root 3. Okay, well, half of 2 is nice. So 16 pi minus 12 root 3. I can't combine those. They're not like terms. That's my final answer. I want to keep that together in parentheses. It's area, so my answer is going to be centimeters squared. Now, you can't always plug that in your calculator and get a decimal. I'll go ahead and do that, and I'll be back in a minute. You try it on your own as well. Again, I believe the preferred answer is here in yellow, 16 pi minus 12 root 3, but Some calculators you can put it in completely using the pi again as the symbol. I ended up with 29.5. So again, just so you can check, but I think this is the preferred answer. Keep that in mind. Okay, we're going to go to the next page. Okay, so we want to find the area of the wood piece in front of the grandfather clock here. So you want to find this wood piece without that center. So pause, see if you can figure these out. This whole length is 42, this is 10. I'm going to cut it up into pieces and find little pieces all together. This is 70, this is 10, that's 21. If this is 11 here, that means this is 11 over here, making this whole length here 22. Which means if it's 22, 42 minus 22 is going to leave me 20. That's going to leave me 10 here, and it's going to leave me 10 over here. So I can find 42 pi 10, this is going to be 420 for this piece. 70 by 10, this piece will be 700. This piece would be 700. So those pieces I can find, length times width, base times height. 7, 7 is 1400 plus 420. I end up with 1820 for those first three little rectangles. Now I've got to find this piece. So what is that shape? Basically, I want they're circles. I want the area of the pink circle, but I don't want the area of the orange circle. I want to subtract out the area of the orange circle. Except, do I want the entire circle, or how much of the circle do I want? Yeah, I only want half of that. So I don't want the whole thing, I want half of that minus that. So area of the pink circle, around 1/2 out here. Area of this pink circle is pi r squared. The radius of the pink is going to be 11 and 11 is going to be, no, 11 and 10. It's going to be 21. Minus the area of the orange circle will be pi, radius here will be 11 squared. So I have 1/2. 21, I get 441 pi minus 121 pi. I end up with 1/2 of 320 pi. Now, this right here, 1/2 of 320 pi is going to be 160 pi. And that's only this right here, though. This right here is 160 pi. I need to add that to my original answer of 1820. 1820 plus the 160 pi inches squared. So you break it apart and you add all your pieces together. This one is a little bit trickier. I am going to pause because I'm doing a little bit of color coding here, and you can come back and see it in a minute and then see if you can answer it. Okay, now this is how I kind of broke it up in my head. I want these two rectangles. Those I can find pretty easy. Here I have half a circle. Here I have a square, which I want this squared, but I don't want this, and that's not quite half a circle, that's about 1/4 of a circle that I don't want. So now that I kind of see what I want, I can start working out. Pause, work it out on your own if you can. I'm going to find all these pieces as best I can, and I'll color code them for you. Area here is going to be 1/2 times 2, length times width. This is going to have an area of 3. That I can do pretty well. 2 times 5, this is going to have an area of 10. So my purple is going to be 3 plus 10, and that's going to be 13. So this is my purple section. Oh, quickly, 1/2 is, right, you could write this as 1 and 1/2. You could change that from an improper fraction to a mixed number, making it 3/2. So if you wanted to do the area of that, this technically is 3/2 times 2, which is where those 2's will just cancel, giving you that area of 3. So that's how I did that kind of quick in my head if you missed that. Change this decimal to a fraction. Always put decimals to fractions if you can. They're easier to work with. Make it a fraction, mixed number, improper fraction, multiply to have your answer. Okay, the next thing I'm going to find is, well, I can probably find this pink one down here. I don't know what color I made that. Not see my gray color. Now, I want to find the area of this. Well, I know the entire thing is 2. So that makes half of it 1, which would be the radius, right? So I have the radius of a circle. This is going to be pi r squared. But I don't want the whole thing. I only want half of it. So now I'm going to take that and I'm going to divide it by 2. I don't want the whole thing, I just want half of it. This is that section. So I'm color coding them so you'll see where they come from later. Again, the radius was 1. 1 squared. We're pretty good there. Now, the next part, I do want the green part. The green part becomes a little bit trickier here. So a green colored pencil. I do not see one. Okay, I do want the green part here, but I don't want all of the green part. The green part, well, this is 2, and this length here, what is this? This is 2. This right here is 1.5. So this is 1.5 here. This is 1.5. So this is 2, 3.5. The side length here is 3.5. 2, 3.5. So it's a square, 3.5. I'm going to take that 3.5. I'm going to make it a improper fraction again. So 3.5 is equal to 7/2. And if I want the area of this, I want 7/2 times 7/2, I get 49/2. So the area of the green is 49/2. No, 2 times 2 is 4. Thanks for catching my mistake. In my head, you guys are all yelling at me. 49/4. Now 4 goes into 49 12 times. So this actual area is 12 1/4. So the green area here is 12 1/4. Now I don't want that entire area. I want to get rid of the orange part. Well, this is 1.5 or 3/2. So the area of this circle would be pi 3/2 squared. But again, I don't want the entire area. I only want 1/4 of it. So I'm going to multiply this by 1/4. So this actually becomes 1/4 pi over 9/4, which is 9/4. No, you're multiplying. 4 times 4, 9/16 pi. So I don't want that though. So I'm going to take this and I'm going to subtract out the 9/16 pi. And that is the last piece. So I create my plan and I go through it a little bit at a time and look at what I have. Now I have to simplify. So as long as I did everything correctly, I can simplify this to come up with my final answer. So 3 plus 10 is 13. 1 squared is 1 pi. So I end up with 13 plus pi over 2 plus 12 and 1/4 minus 9 over 16 pi. So what we want to do is we want to add our like terms together first. So here we have 13, 12. Add those together, you get 25 and 1/4. And then can I take pi over 2, let me do this work down here, pi over 2 minus 9 pi over 16. I need a common denominator of 16, I'm going to have to multiply by 8. 8 pi minus 9 pi over 16, I'm going to end up with a negative pi over 16. 8 squared. This is an ugly problem. This is not one that you will see a ton of, but it is always nice to kind of know that you can go through it. You know, you can go through it step, piece by piece, and kind of figure everything out. Again, just to highlight so you know where this came from. This and this I put right here. And got this answer. So that's our final answer. Yay! Okay, down here we have two problems. We have a law of sines problem over here and a law of cosines problem over here. I'm going to pause because this is getting long, and I'm going to set it up. So pause, see if you can set it up, then come back and check it out. A few typos, I was like, what is going on? So I had to go figure this out. We're actually looking for DF here, which is my x. We need this angle 112. And over here we're looking for angle T. So there were a few typos here, if you want to go back and try to figure that out now. Starting my law of sines here, I'm going to do the setup for this, and I'm going to write the setup over here, and then I'll be back. Okay, I'm going to talk through some of the work. It was x over sine of 31 equals 8 over sine of 112. I'm looking for the x, so that goes up top. Multiply both sides by sine of 31 here, so I get 8 times sine of 31 over sine of 112. I'm going to put that in my calculator in just a minute. Now over here we're looking for t, which would be the biggest angle. So 12 squared equals 6 squared plus 8 squared minus 2 times 6 times 8 cosine of t. Well, 36, 64, I get 100. 2 times 6 times 8, I get 96. Remember, you cannot subtract these. You have to subtract the 100. So I brought my work down here. I got 44 equals negative 96 cosine of t. Now when you're getting your cosine t by itself, now I divide. 44 divided by negative 96 gives me 0.4583 cosine t. Well, remember, when you're looking for the angle here, we need to do inverse cosine of this number. Negative 0.4583, or inverse cosine, if we didn't have a calculator, 44 over negative 96. That's what we would have put in if we didn't have a calculator. Having a calculator, we can work it out all the way. So I'm going to go ahead and do those just so we can check. 8 sine 31 divided by sine of 112 gives me approximately 4.4. Over here, I have inverse cosine of 44 divided by negative 96, and I get approximately 117. I usually in degrees there. Sometimes I want to go 1 decimal, 0.3 degrees. So there you go. Check your calculators, make sure that those are working. And that is it for the notes today. Good luck. Sorry they were so long. Have a fabulous day. See you guys next time.